Welcome to our deep dive into the solar system.
Yeah.
We're going to be looking at this NASA professional development training that they made for teachers.
Oh, cool.
And, you might be thinking, well, I'm not a teacher, so why should I care? But
Yeah.
we're going to pull out all the cool stuff that'll make you feel like you're actually at the workshop.
Right. And what's really interesting about these materials is they take all these really complex ideas and present them in a way that makes you want to learn more.
Yeah, exactly. Okay, so one of the first things they do in this training is an activity called sorting the solar system, where you're supposed to look at all these different objects and put them in categories. And it got me thinking,
Okay.
how many stars are even in our solar system?
Oh, that's a great question. And actually, that's a really a good point to start with because there's only one star in our solar system.
Oh,
And that's the sun. And everything else that we consider part of our solar system, all the planets, asteroids, comets, they all orbit around the sun.
so it's like the sun's entourage.
Yeah. It's like the sun's family.
That's a better way to put it.
Yeah.
The sun's family.
Yeah.
But there's a lot going on
Yeah.
in that family. You've got planets, you got asteroids, comets. Like, how much stuff is out
Oh,
there?
there's a ton of stuff. And just think about the planets. We have 8 planets, and they're all so different. You have tiny Mercury that's super hot because it's so close to the sun.
Yeah.
And then you have Neptune, which is a giant planet that's made of ice and gas,
Wow.
billions of miles away. And then you have the asteroid belt, which is just this huge collection of rocks that are between Mars and Jupiter. And then the comets, they're like these icy snowballs that are flying all over the place.
Wow. That's a lot to keep track of.
Yeah.
Well, speaking of a lot to keep track of, they have this one activity that really caught my eye. It's called Jump to Jupiter.
Oh,
Please tell me they didn't actually make teachers jump around.
they did. Well, they created a scale model of the solar system where the sun was the size of a grapefruit. And to show how far apart everything is, they had them jumping
Oh, I see.
from planet to planet.
Okay.
So in this model, Earth was the size of a poppy seed.
A poppy seed.
Yeah, tiny. And Jupiter was the size of a marble.
Wow. That really puts it into perspective, like
Yeah.
just how much space is out there.
Exactly. And I think that's why they had them, moving around
Yeah.
to really feel those distances.
It makes you realize those sci-fi movies where they're like, oh, yeah, we're just going to hop over to this galaxy.
Right.
Not so realistic.
Yeah, it takes a bit longer than that.
Yeah, a bit longer than that.
Okay.
Because another activity that really stood out to me was this one called Splat, where they simulated asteroid impacts on the moon using water balloons.
Oh, that's a fun one.
What was the point of that one?
So they found that when you drop a water balloon and it makes a crater,
Uh-huh.
that the crater is actually 10 to 20 times larger than the water balloon.
Wow.
And that shows just how much force is involved when an asteroid hits something.
Yeah, that's kind of scary.
It is. I mean, even a small asteroid going super fast can make a huge crater.
So craters aren't just like a little dent.
Right.
They're like a massive explosion almost.
Yeah, exactly.
Wow. Okay, well, this deep dive is already blowing my mind. One thing I've always wondered is how do scientists even know what's inside a planet?
Yeah, you can't exactly cut one open.
You can't cut it open. Like, how do they figure that out?
Well, the training tackled that with an activity called investigating the insides. And in this one, they had the participants try to figure out what was inside a sealed balloon
Okay,
without opening it.
that sounds hard.
It is, but they could shake it, weigh it, use magnets, anything to try and figure out what was inside.
Oh, that's clever.
Yeah, so it's like they're being detectives
Yeah.
trying to figure out the clues.
Right, so it's like planetary scientists, they can't cut open a planet, so they have to use these indirect methods to figure out what's going on.
Exactly. They look at things like magnetic fields, gravity, and even things like volcanoes and canyons to get an idea of what's happening beneath the surface.
So cool. I love that these activities are like mini science experiments
Yeah.
that make it all so much more hands-on.
Yeah, it's way more engaging than just reading about it in a textbook.
Absolutely.
Yeah.
Okay, let's talk about space rocks.
Okay.
They had this activity called edible rocks, where they use candy bars to learn about meteorites. So tell me about that.
Well, they use different types of candy bars to represent different features of meteorites.
Okay.
Like, for instance, the Nestle Crunch Bar with its crunchy bits.
Yeah.
They use that to simulate chondrules, which are these tiny round grains you find in some meteorites.
Chondrules, what are those?
So chondrules are basically tiny droplets of melted rock that cooled really quickly. And they're really important because they tell us a lot about what the early solar system was like.
So they're like little time capsules from the beginning of the solar system.
Yeah, exactly.
That's so cool. Okay, so that's the Nestle Crunch. What about the fusion crust? You know, that outer layer that melts when a meteorite enters the atmosphere.
Oh, right. So for the fusion crust, they used a Three Musketeers bar because it has that smooth melted exterior.
Oh, okay, I see.
Yeah, it's all about making these analogies
Yeah,
to help people understand.
that's brilliant. So you're learning about space rocks while eating candy.
Yeah, it's a win-win.
It's a win-win. But seriously, why are meteorites so important? Like, why do scientists care so much about these space rocks?
Well, meteorites are like puzzle pieces from the early solar system. By studying them, we can learn a lot about how the solar system formed and evolved. We can learn about what the planets are made of and even how life might have arisen.
So they're not just random rocks, they're like clues to the history of the universe.
Exactly.
That's amazing.
Yeah.
And what about Martian meteorites? Like, how do we even know they came from Mars?
That's a great question. So we know these meteorites came from Mars because their composition matches the rocks we've seen on Mars. Oh.
Okay.
From the rovers and orbiters we've sent there.
So it's like having a little piece of Mars right here on Earth.
Yeah, and they can tell us a lot about Mars, like whether there was ever life there.
Wow, that's mind-blowing. I feel like I'm learning so much from this training. It's so much more engaging than just reading a textbook or something.
Right. It's really making me think about the solar system in a whole new way.
Me too. What else did this workshop cover? I'm hooked.
Well, they also talked about how scientists study the interiors of planets, and they even had this activity where they simulated this using balloons. It's really interesting.
Okay, we got to talk about that balloon activity. I'm intrigued. How did they use balloons to simulate studying the inside of a planet?
So imagine a balloon filled with a bunch of different stuff, maybe sand, marbles, water, stuff like that, but you can't see inside.
Right.
So they had to use different tools like magnets and scales and even their own senses to try and figure out what was in there.
Oh, that's so cool.
Yeah, like they had to be detectives using clues to figure out the mystery.
So it's kind of like how scientists study planets.
Exactly.
They can't just cut it open, so they have to use these indirect methods.
Right. They look at the magnetic field, the gravity, the volcanoes, and all that to try and get an idea of what's going on deep down.
It's amazing how much we can learn without even setting foot on another planet.
It really is.
Scientists are like cosmic detectives.
They are.
Okay, I'm officially obsessed with this deep dive. It's like we're getting a backstage pass to how scientists explore the solar system.
Yeah. It's pretty cool.
All right, well, I'm eager to hear more, but I think we need to take a little break.
Okay.
We'll be back soon with part 2 of our deep dive into the solar system. Stay tuned.
Sounds good. Welcome back to our deep dive into the solar system. We're continuing our exploration of this NASA training and seeing all the really creative ways that they teach about space.
It's amazing how much we can learn from these hands-on activities. Like in the last part, we were talking about how scientists study what's inside planets without actually cutting them open.
Yeah, right. It's like they're solving a puzzle with invisible pieces.
Exactly. And speaking of puzzles, this training had a really interesting activity called Strange New Planet. What was that all about?
So in Strange New Planet, the participants get to act like real planetary scientists. But with a fun twist, they're given a model of a mysterious planet, and they have to use their observation skills to figure out all sorts of things about it.
Oh, cool. So they're like detectives trying to solve a cosmic mystery.
Exactly. They can look at it from different angles, use telescopes to zoom in, and they can even send probes to investigate the surface.
Wow, that sounds like a lot of fun.
It is. And just like real scientists, they have to consider all the possibilities and sometimes even change their minds as they gather more information.
It's a great way to show how science really works. It's not just about knowing all the answers. It's about asking the right questions and being open to new discoveries.
I agree. And this training does such a good job of making science exciting and accessible to everyone.
Yeah, like that edible rocks activity we talked about earlier where they use candy bars to learn about meteorites.
Oh, yeah, that one was delicious.
It was. And it was a really clever way to show how scientists classify meteorites based on what they're made of and how they look.
Right. They use different candies to represent different features, like the crunchy bits in a Nestle Crunch bar to represent
I
chondrules.
remember those chondrules are like tiny little time capsules from the early days of the solar system.
Exactly. And then for the fusion crust, that smooth outer layer, they use the Three Musketeers bar.
It's like science you can eat.
I know, right? But all jokes aside, why are meteorites so important to scientists? What can we learn from them?
Yeah, they're more than just cool space rocks, right?
Way more. Meteorites are like pieces of a giant cosmic puzzle. They hold clues to how our solar system formed and how it's changed over time.
So by studying them, we can learn about the history of our entire cosmic neighborhood.
Precisely. And some meteorites, like those from Mars, can even tell us about the possibility of life on other planets.
It's amazing to think that something that falls from the sky can tell us so much about the universe.
It is. And it shows how everything in the solar system is connected in some way.
Yeah. And speaking of connections, we talked a bit about planetary migration in the last part, the idea that planets can actually move around within a solar system.
Right. It's not as crazy as it sounds. There's a lot of evidence that suggests that Jupiter, for example, might have migrated inwards towards the sun early in its history.
Wait, so Jupiter, the biggest planet in our solar system, just decided to take a stroll. How is that even possible?
Well, it's all about gravity. The gravitational pull from other planets or even smaller objects can nudge a planet's orbit over time.
So it's like a giant cosmic dance with planets tugging and pushing on each other.
Yeah, and these movements can have a big impact on how a solar system evolves. They can disrupt orbits, scatter objects, and even influence the formation of planets themselves.
Wow, this is making me rethink everything I thought I knew about the solar system.
I know, right? It's a lot more dynamic and complex than we often imagine.
And speaking of complexity, one thing that's become really clear from this NASA training is how crucial space missions are to our understanding of the solar system.
Absolutely. Every probe we send out, every rover we land, gives us a new piece of the puzzle, helping us to see the bigger picture.
What are some of the missions that have been most important, in your opinion? Like missions that have really changed the way we think about the solar system?
Oh, there are so many. But the Voyager missions always come to mind. Those two spacecraft have been traveling for over 40 years, sending back incredible images and data from the outer planets and beyond.
Yeah, I remember seeing those pictures of Jupiter's Great Red Spot and Saturn's rings when I was a kid. They were mind-blowing.
I know. And Voyager didn't stop there. It went on to explore Uranus and Neptune, giving us our first close-up views of these icy giants.
It's amazing to think those spacecraft are still out there, sending back information from the edge of the solar system.
It's a testament to the power of human curiosity and the incredible things we can achieve when we work together.
And Voyager is just one example, right? There have been so many other important missions like Cassini, which explored Saturn and its moons.
Yes, and Juno, which is currently orbiting Jupiter, giving us unprecedented insights into its atmosphere and magnetic field.
It's incredible to think about all these spacecraft out there silently exploring the cosmos and expanding our knowledge of the universe.
It's a golden age of exploration. And with each new mission, we learn more about our place in the vastness of space.
Well, I, for one, am feeling very inspired by this deep dive. It's like a reminder that there's still so much out there to discover and that we're constantly learning new things about our cosmic neighborhood.
I agree. It's a feeling of wonder and excitement that I think everyone should experience.
Okay, well, I'm ready to hear more, but I think it's time for us to take another quick break. We'll be back soon to wrap up our deep dive into the solar system with part 3, so stay tuned. Welcome back to our deep dive into the solar system. We're wrapping up our look at this NASA training, and it's really been an eye-opener.
It has. We've talked about everything from the sheer size of the solar system to the tiny details of meteorites.
And in the last part, we were discussing the Voyager missions. Those spacecraft have been traveling for over 40 years. It's incredible to think they're still out there sending back data.
I know, right? They're like pioneers venturing into uncharted territory.
Speaking of pioneers, this training also emphasizes the role of observation in science. There's an activity called Strange New Planet, where you get to pretend to be a planetary scientist.
Oh, yeah, that one's fun.
You have to use your observation skills to figure out everything you can about this mysterious model planet.
It's a great way to experience what it's like to be a scientist, gathering data and trying to make sense of it all.
You can look at the monitor from different angles, use telescopes, even send out probes to investigate the surface.
It's like putting together a giant puzzle.
Yeah, and it shows how important it is to pay attention to every detail.
Every clue could be important.
Right. It reminds me of how scientists analyze meteorites, those space rocks that hold so much information about the early solar system.
Oh, yeah, those are fascinating. We talked about the edible rocks activity where they use candy bars to represent different types of meteorites.
It's such a clever way to make learning about them fun and engaging.
And it really helps to visualize those concepts, like how the crunchy bits in a Nestle Crunch bar represent chondrules.
Yeah, those tiny time capsules from the birth of the solar system.
By studying those, we can learn so much about the conditions that existed billions of years ago.
It's amazing how much information we can extract from something as seemingly simple as a candy bar.
It shows that science is all around us, if we just know how to look for it.
This whole deep dive has been a reminder of that. It's rekindled my sense of wonder about the universe and the incredible discoveries that are still out there waiting to be made.
I feel the same way. There's so much we don't know, but we're constantly learning and pushing the boundaries of knowledge.
It's an exciting time to be interested in space. So if you could send a probe to any planet in our solar system, where would you send it and why?
Ooh, that's a tough one. There are so many intriguing places to explore. I think I'd send it to Uranus. It's kind of the forgotten giant. We know so little about it.
Yeah, that's a good choice. I'd love to see more detailed images of its rings and its tilted axis.
Right, and its moons. Some of them might have hidden oceans beneath their icy surfaces.
Wow, that would be an incredible discovery.
It would. It just shows that there are still countless mysteries out there in our own solar system.
Well, I think we've come to the end of our deep dive into this amazing NASA training.
It's been a blast.
Thank you so much for joining us in this episode of The Deep Dive. We hope you've enjoyed exploring the solar system with us.
And we hope it sparked your curiosity about space.
Keep looking up and never stop wondering.
Until next time.